at my project 3. So for project 3, I need NumPy, I need support vector classifier. So I am importing SVC support vector classifier from Scikit-learn.svm. Similarly, I am importing train test split from Scikit-learn.model selection. I am importing matplotlib. I am importing pandas and seaborn as well. So let's run this cell in order to import these files in our Google Colab environment. Now in this project, I am going to use the Titanic_train.csv dataset. We already know about this dataset. We have seen and we have worked on this dataset in the previous sections of the course. Let's import this data. So we know that in order to import the data, we need to mount the drive and we need to set the path. Therefore, in order to save the time for this particular project, I have already mounted the drive. I have already set the path. So let's run this cell. And the drive has already been mounted. Okay, the path has been set. So if we see here, the path is drive, my drive, course material, and supervised machine learning. Here is support vector machine, and inside support vector machine, here you can see that I have Titanic train dataset. So this is the path which I have set. Now it's time to import the dataset. So let's run this cell. So we have successfully import our dataset known as Titanic train dataset, and the dataset is known as a train here. This is the shape of the dataset. So we can see we have 891 samples and we have 12 columns. Let's see the head of the data. So these are the first 5 samples of the data. We can see that from passenger ID to embarked, we have quite a few number of columns here. Okay, so the first column is passenger ID. The second column is survived. So we are going to use this column as our label. It has two kind of different values or unique values, that is 0 and 1. 0 means whether the passenger, 0 means the passenger died during the accident, and 1 means the passenger survived during the Titanic accident. So this is the passenger class, the name of the passenger, the sex of the passenger, age. This column represents the sibling and the spouse of the passenger. This represents the parents and the children. Okay, so this is ticket number, fare, cabin, and embarked. Embarked means from where the traveler mounted from. So these are the 3 different places, that is Southampton, Cherbourg, and Queenstown. So if we see here, this is not a new data set for us now. We have a different kind of features here. Few of the features are irrelevant. Few of the features are a categorical feature, like sex is a categorical feature, embarked is a categorical feature. So we will deal with these different kind of features. Okay, now check the number of passengers died. Since we are going to use the column survived as our label, let's see the values inside this column. So my data set is train and survive is the column. Let's check the value counts. So if I run this cell, I can see that I have two kind of different variables, 0 and 1, different values, basically 0 and 1. So these are my label for the data set. So out of all these values, 549 passengers died and 342 survived. So there is a 60% of the passengers who died in the accident. Now drop the irrelevant feature. So passenger ID, name, ticket, cabin, these are the 4 columns or features which are irrelevant. Irrelevant mean they have no influence on our labels. So let's remove or drop these features and we are going to make it a permanent change. Let's run this cell. Okay, and now check for the null values. So these are the columns which are left, or these are the features which are left after removing or dropping the irrelevant features. Now it's time to check the null values. So train.isNull.any, is there any null value? Let's run this cell and see. So we can see that we have a null value in the column called age. It is true for the null value, and similarly we have null value in the column called embarked. So let's see how we can deal with these two features. So if we go back and see here, the age column has a value in the form of float. So here what we will do with the null values, we will calculate the average or the mean value of this column and replace the null value with the mean value. Okay, so I am going to fill NA. Fill NA means I am going to fill the null value of the column age with the mean value of the column. So here in this step, I am going to calculate the mean value of the column called age, and I am replacing all the null value with the mean value, and I am going to make it a permanent change. That's why in place is equals to true. Now after this, let's check the null values again. So we can see that there is no more null value in the age column now, and only the embarked column is left. So what we can do now, because embarked is the categorical feature, therefore we can drop those rows of our data containing null values. So here I am going to drop those rows of our data containing the null values. Okay, now all the rows we have already dropped the rows containing the null values. Now it's time to check the null values finally. So we can see that there is no null value left here, and all the null values have been either removed or have been replaced by the mean of the column. And now this is our head of the data set. So now we have to deal with the sex and embarked. These are two categorical features, and we know how to deal with the categorical features. So basically we are going to create the dummy variable for the column sex and embarked, and we will also drop the first column of the dummy variable by writing a command drop first is equals to true. Let's run this cell. We have done this step many times now in this course in the previous sections. Okay, now add dummy variables to the original data. So sex is the dummy variable for this column, and embark is the dummy variable for the column embark. Okay, let's concatenate these dummy variable to our original data set, which is train. So this is our original data set train. Sex and embarks are the dummy variable, and now we are going to concatenate these with the data. Let's run this cell and see. So we can see that here we have the dummy variable male for the column sex, and we have the dummy variables q and s for the column embarked. Now the dummy variables for sex and embarked column has been created. Now it's time to remove these dummy variables, remove these sex and embarked columns, because their dummy variables has been created. So we can see now it's a data set with no categorical features, and there are no missing values. Now we have done all the pre-processing steps with this data set, and we can see that the sex and embarked column has been removed because their dummy variables have been created. Now we are left with survived column, passenger class, age, and sibling, spouse, parents and children column, fair, male, Q and S. Q stand for Queenstown and S for Southampton. Now this is a clean data set. There is no missing value. There is no categorical feature. Now it's time to extract features and label. Now, other than this survived column, all the columns are our features. Therefore, in order to extract the features, I am going to drop this survived column, and rest of all the columns are my features. So let's run this cell. But for labels, I need only the column known as survived. Let's run this cell to get the labels. So I have my features, I have my label. Let's perform a train test split. So for train test split, I am passing X and Y, that is my features and label, to this function. The testing size is 20%, that is 20% of the data I am going to use as a testing data, and remaining 80% will be used as a training data. Here I am passing random state is equals to 42. Let's run this cell. Let's check the shape of the testing data. So we have 78 sample now in our testing data, and we have 8 features. Okay, now it's time to standardize the data. So for standardization, I am going to import standard scalar from sklearn.preprocessing. Okay, so here I am instantiating the standard scalar, and I am calling it SC. Here I am transforming my training component of a data into standardized form, and here I am standardizing the testing component of my data. Let's run this cell to perform the standardization of the data. Now it's time to apply support vector machine here. So for support vector machine, I am passing a kernel RBF. The value of C is equals to 1, and the gamma is equals to scale. So in project 1 of this section, we have learned about these things, that these 3 are the important input parameter for the support vector classifier. So here I am instantiating them, and here I am fitting my support vector classifier to the training component of our data, and here I am getting the predictions. So here I am basically training my support vector machine on the training component, and after getting training, I am getting the predictions from my trained model. Okay, let's run this cell. So I have the predicted values of the model, and I have my original test label. Let's calculate the accuracy here. So the accuracy is 80.9%. So it is very close to 81%. Okay, now gets the confusion matrix. So here I am calculating the confusion matrix, and we can see that this is 95 and this is 49. So the values along the diagonals are those number of samples which are classified correctly. So this is our misclassification value, first 14, and this 20 is also our misclassification value. Let's create the confusion matrix in the form of image. So here I am importing the confusion matrix from Scikit-learn.matrix, and also I am importing a function confusion matrix display so that I can display the confusion matrix in the form of image. This is very standard stuff. You have seen this before. So let's run this cell. So we can see that this is our another form of the confusion matrix, or this is the image of the confusion matrix. We have the classified values, the correctly classified values along the diagonal of the confusion matrix, and this is our misclassification, and this is also our misclassification. Now it's time to use grid search cross validation. So without grid search cross validation, we reach up to the accuracy of 80.9%. So we know what is the concept of grid search cross validation. So basically in grid search cross validation, we pass all the possible combinations of input parameter to the model, and we let the model to decide what are the best parameters. So for this, here I am importing k-fold from Scikit-learn.model selection, and I am also importing grid search cross validation from Scikit-learn.model selection. So I am using split is equals to 5. That is, I am using 5 splits for grid search cross validation. Okay, here I am instantiating my support vector classifier, and this is the most important step of the grid search cross validation. Here I am passing my 3 important parameter to the model so that model can select the best parameter. So this is the possible combination of the value of C, which is used to select whether the support vector classifier is a soft classifier or a hard classifier. This is the option of a kernel. We know that we can use a linear kernel in support vector classifier, and we can also use radial basis function. Gamma, usually we use auto or scale, but we can also pass the range of float to this variable. So here I am passing 1.1, 0.01, 0.001, and 0.0001. Here I am not using scale or auto, but I am passing a range of floats value to a gamma. Okay, so here I am passing these parameters to the model, and here I am fitting this to a model so that model can provide us the best parameters. Let's run this cell to get the best possible combination of the parameters, that is the value of C, the value of kernel, and the value of gamma. So we are going to find these values from our model by passing or by training the model on the training component of our data, and we have passed all the possible combinations of these input parameter to the model, and let's see what are the best possible combination which the model will select. So we can see that it is still running because we have passed quite a few numbers of values. This is a big possible combination for the value of C. Similarly, the option for the kernel is a linear and RBF, and we have also passed the gamma values from 1 to 0.0001. So these are basically 5 different values of the gamma. So here we did not pass scale and auto, which we usually pass. But if we see the documentation of the support vector classifier, which we saw in our project 1, we can also pass the floating values to the gamma as well. Okay, so here our model is running, and we can see that we are going to get the best possible parameters from our model. So if we see this line of a code, here I am passing the k-fold, and the value of k is 5. So basically this is 5-fold cross validation, and the random state is equals to 42, so that every time I get the same values in my split. That's why I have passed the random state is equals to 42. The shuffle is equals to true. That is, after every split, it will shuffle the data so that the different data combinations will pass through the model, and model learn the every possible combination of the data so that it can select the best possible value for the parameters. So it is taking a time, and we have to give a time to the model so that it can provide us a best possible value. We have to remember that we have achieved the accuracy of around 81% without cross validation. So let's stop this lecture here, and I will continue this project in the next lecture. See you there.